All right. Section 4.5, the fundamental theorem of algebra. Believe it or not, we've been talking about it. So homework due next Tuesday, as usual. So objectives, we're going to apply the fundamental theorem of algebra, the number of zeros theorem, and the conjugate zeros theorem, and solve polynomial equations having complex solutions. So first off, I wanted you to modify the notes and scratch off what I did. And the example is just to find the zeros of x to the fourth minus x cubed plus 9x squared with no factors given, no k values, no zeros, nothing. Okay, so what does the fundamental theorem of algebra say? It says it guarantees that every polynomial has a complete factorization, provided we are allowed to use complex numbers. So complex numbers, back from our first time that we did pre-recorded notes, have the is that letter I, because they're imaginary. So what the fundamental theorem of algebra says here is that the total number of factors equals the highest degree of the polynomial. So far, like I've said, is that we started off easy, and here we're just going to give a brief little introduction. You go into this so much more in depth in pre-cal. But the degree of the polynomial is technically how many factors you have. They can all be real, or some could be imaginary, or they could all be imaginary. So let's see for this problem, let's see what we come up with. But before that, the conjugate zeros theorem. It says if a polynomial f of x has only real coefficients, and if a plus bi, again the imaginary part, is a zero of f of x, then the conjugate, take this off, a minus bi is also a zero of f of x. So the conjugate, the only difference, so if you're given one of them and it has a plus, then the other one is going to be the exact same but with a minus, and vice versa. And they travel in pairs. So I'm going to write that down. Imaginary answers travel in pairs. Not one of them is going to be by itself. If I have a minus bi as an answer, if I have one imaginary, then the opposite is also an answer. So they travel in pairs. So I'm going to put here itself, itself and its opposite. Okay, so examples, and technically it's just one. Find the zeros of x to the fourth minus x to the power of 3 plus 9x squared. So because of this 4, I'm going to put it here. We can have the following types of answers. So because of the 4, the following types of answers are as follows. All 4 of them can be real. I shouldn't say all. I can have 2 real and 2 imaginary because they total 4. But 3 real and 1 imaginary are not possible, again because they travel, the imaginary ones travel in pairs. And by the same token, 1 real and 3 imaginary is not possible either, because the imaginaries travel in pairs. So the other possibility is that they can be all 4 could be imaginary. Because I can have because I can have two pair of imaginary, itself and its opposite, and then another pair of imaginary, which is itself and its opposite. So let's see what this one right here. I know you might want to just see what it is graphically. So before we start off graphically, we need to understand, again, we've been doing this for 2-3 weeks, even before the break. We need to understand that we want to find the zeros. Graphically, we're trying to find the x values of the x-intercepts. So here we go. Let's graph it, and then we're going to get it algebraically. So x to the power of 4 minus x to the power of 3 plus 9x squared. And so we have, it's a power of 4 with an understood 1 in front of it. And so here, it's end behavior is that both arrows are up, and it looks like it's not coming back down. It can't. Okay, so we have, technically, it looks like only one answer. But based on the previous notes, if you notice, the graph here touches the x-axis. So that means we have a factor here that, well, this factor right there, which is 0, that factor appears twice. Okay, so let's put it into play here now algebraically. Here we go. So if I'm going to find the zeros, this means also that the y values is 0. Therefore, I'm going to do this right here. I'm going to have x to the power of 4 minus x cubed plus 9x squared is going to be equal to 0. And so now I'm going to be in factoring mode and try to use everything that we've learned so far. So x to the 4th minus x cubed plus 9x squared, they all have a x squared in common. So I'm going to factor out an x squared. So x squared goes on the outside. X squared times x squared is going to give me x to the 4th. X squared times a minus x will give me x minus x to the cubed. And x squared times a plus 9 will give me 9x squared. Now we have this is a quadratic, and we can try to factor it. And so we have a 9, and here we have a understood minus 1. So unfortunately, there are no two numbers that multiply to give you a positive 9, because it's either just 1 and 9 or 3 and 3, and that they're going to add up to a negative 1. So either one of two things is the issue. Either they're just ugly numbers that are decimals or square roots or irrational numbers, or like we just confirmed graphically, they are imaginary. So if we can't guess and check, we're going to use the quadratic formula. So before we do that, so this is technically factored, so I'm going to go ahead and put here so that we can reiterate that this right here, this x squared, and that parentheses are being multiplied. So we technically now we set each factor equal to 0. So set each factor equal to 0. And so we have x squared is equal to 0. And we're going to have x squared minus x plus 9 is equal to 0. So if you notice, this right here, I can actually write it as x plus a 0 or minus a 0 for that matter. Quantity squared is equal to 0. And this one, the opposite, I can say x plus 0 is equal to 0. So technically, x is equal to 0. Because of this, that's horrible. Sorry. Because the factor or the degree here is 2, it has a multiplicity of 2, then we know that it just touches the x-axis, which we already confirmed. So that x equal to 0 again is an answer technically twice. And again, maybe we can see it here because I can write it as x times x is equal to 0. Well, this can be 0 or this one can be 0. Either one would give me a 0. So that's why I have two answers there, but it happens to be the same answer. Okay, so now this one, we cannot, it's not factorable. So I'm going to put here, not factorable. Oh, hang tight. I'm just seeing myself here. I jumped the gun. Darn. So right here, I apologize. Another thing that you can see here, I jumped the gun. So this is x squared is equal to 0. So how is it that we get rid of a squared? I can take the square root. And so the left side is just x. And here's another reason why you can see the plus and minus. So remember, when you have an equation and you take the square root, you can't forget that technically it's plus and minus 0. But again, and there's two answers here, plus 0 and minus 0. But again, in actuality, it's the same answer. Okay, so going back to this one. So x squared minus 9 minus x plus 9 is not factorable. So therefore, we're going to use, we could use the completing the square, but we can use the quadratic as well. All right. So my a is equal to 1. My b is equal to -1, and my c is equal to 9. And so the formula x is equal to -b plus or minus b squared minus 4 times a times c, all divided by 2 times a. I'm going to go in and substitute them. So -1 plus or minus -1 squared minus 4 times 1 times 9 over 2 times 1. So I'm going to go ahead and come up over here. And so I'm going to have x is equal to, so -1 is a positive 1, plus or minus square root. So if we do this on the calculator, or the noodles that God gave us, -1 squared is 1. And then I have minus 4 times 1 times 9 is going to be minus 36. So 1 minus 36 is -35. And again, you can use your calculator. And 2 times 1 is 2. Because of this part, which part? Because of this, we cannot take the square root of a negative. So that's why we know now that our answer is in fact imaginary. But we're going to actually be able to put some numbers in it, but it's going to have an imaginary part. So this is going to be x is equal to 1 plus or minus, and technically, just a nice little review from our previous recorded notes, this is going to be -1 times 35. We can't factor anything else as a perfect square, and there's no other simplification process. And the square root of -1 is I, so it's going to be 1 plus or minus I. And the square root of 35 is but ugly. It's just 7 times 5. They're both prime. They have no perfect square roots there. Over 2. And so how many answers do we have here? We have 2. So it's going to be x is equal to 1 plus I square root of 35 over 2. And the other one is 1 minus I square root of 35 over 2. And so our final answer is x is equal to 0. And again, remember that 0 actually appeared twice, but we're only going to write it once for efficiency. And 1 plus I square root of 35 over 2. And minus I square root of 35 over 2. So in this case, out of these 4 possible scenarios, this is the one that happened in this particular equation. We had 2 real, but again, it was the same answer repeated. That's why it touched the x-axis, and 2 imaginary. So we can say this was the real answer, repeated twice. And then these are the 2 imaginary. Okay. Next one. Solve the polynomial equation, find all the solutions. Okay, so maybe I know Desmos has been really nice to us, but now you can see that Desmos itself will have some limitations because it cannot show you the imaginary answers. So, oh well. So this one, solve the polynomial equation, find all the solutions. I've told you that you can use Desmos to try to find the solutions to see where they intersect. So here, let's do this one. So on one side, I'm going to do x to the power of 4 plus x to the power of 3. So that's this equation right there. Highest power of 4, a is greater than 1, so it looks like that. And on the other side, I have negative x squared, which is just a parabola upside down. So where is it that they are going to intersect? So I'm going to zoom in here. That's the beauty of Desmos. So if you notice, we have one answer right there. All right. Let's get it algebraically. Here. So solve the polynomial equation, find all solutions. So I'm going to set the equation equal to 0. Again, this means I'm looking for x-intercepts. So in order to do that, that negative x squared has to come on over. So let me just write the equation again. So x to the 4th plus x cubed is equal to negative x squared. I'm going to add x squared to both sides, and they don't combine with anything, but I'm going to go ahead and write them in descending power. So this is going to be x to the fourth plus x cubed plus x squared is equal to 0. Hang tight. Okay, so we're in factoring mode. Let's first see if they have anything in common. So let's factor out an x squared. So it's going to be x squared is going to be x squared plus x plus 1 is equal to 0. And I should have asked at the beginning, but that's okay, I'll ask right now. Again, our highest power, our highest degree is 4. So for this 4, again, we have the same scenario as the previous one. So our 4 here means 2 real, 2 imaginary, but technically, well, I'm not going to write them again. You need to understand, they're up at the top. So the degree of 4 means we're going to have 4 factors. So why is it slowing down? I'm not too sure. But the same 4 scenarios that are up at the top are applied here because we have the same degree. This is the first time in this lesson, actually in any of this polynomial stuff that we've gone over, that we've seen a power to the 4 other than when we were doing our end behavior analysis. But anyway, so we have 4 factors. Okay, so right now we have this so far. So we're gonna do x squared is, we're gonna set each factor equal to 0. I should write that down. And so this one right here, I can take the square root of both sides, and I get x is equal to technically plus or minus 0, which is just x equal to 0. And again, since we have a multiplicity of 2, therefore it's going to touch the x-axis. And we already saw that it did. And for this other one, we want to, we can't factor it because we're looking for 2 numbers that multiply to give you a positive 1 and add up to 1. So 1 times 1 and 1 is going to give me either 2 or negative 2 or a 0 if I were to add them up. So again, here we can, we can use the quadratic formula, or we can complete the square. So on this one, I'm going to complete the square just because we probably need practice on it. So for completing the square, we move the variables on one side so that minus 1 has to, the plus 1 has to go. So I'm going to subtract 1 from both sides and I get negative 1. And then I'm going to take half of this value right here, which is an understood 1. So I'm going to write that down. I'm going to take half of 1. So that's going to be a half. Then I'm going to square it. So a half squared is a fourth on a good day. And then I'm going to add it to both sides. So I'm going to have x squared plus x plus a fourth is equal to negative 1 plus a fourth. And this process right here is actually x plus 1/2 squared. And where did I get the 1/2? This plus 1/2 is half of whatever we took the half of. And it's going to be equal to, so -1 plus 3/4. So -4/4 plus 3/4 is -3/4. And I'm going to run out of space here. But here on this one, again, I want to solve for x. So I'm going to take the square root of both sides. To get rid of the squared again. And so on the left hand side, I'm going to be left with x plus 1/2. And on the right hand side, I'm left with the square root of -3/4. We cannot take the square root of a negative. So I'm going to leave technically the square root of -3 becomes I square root of 3 because it's -1 times 3 and the negative square root of -1 is I. Square root of 3 is but ugly, so we keep it in the square root. And the square root of 2, the square root of 4 is 2. And again, I do not forget the plus minus. And so now I need to get rid of this plus 1/2, so I'm going to subtract a half from both sides. And so I'm going to be left with x is equal to -1/2 plus or minus I square root of 3 over 2. And so I have two imaginary numbers right there. So my final answer is x equal to 0. Repeat it twice. And -1/2 plus or minus I square root of 3 over 2. And actually I'm going to separate them so that you can see that there were, but there's 4. So I have the plus and I have -1/2 minus I square root of 3 over 2. So I have a total of 4 answers.